Hey guys, Ketan again. Today we are doing another problem from beginner level CodeChef. So the problem that we are doing today is sums in a triangle. Okay, here is the problem code. SUMTRIAN. Let's go through the problem statement. Let's consider a triangle of numbers in which a number appears in the first line, two numbers appear in the second line, three in the third line, etc. Develop a, develop a program which will compute the largest of the sums of numbers that appear on the paths starting from the top towards the base, so that on each path the next number is located on the row below, more precisely either directly below or below and one place to the right. The number of rows is strictly positive but less than 100. All numbers are positive integers between 0 and 99. Right. So guys, so first of all there will be a test case, number of test cases, and then followed by n value here. So this value is used to designate how many number of rows will be there in our triangle. I'm calling it a triangle because each row doesn't have same number of columns. The number of columns in a row is based on the row's position. For example, the first row has one column, second row has two columns, third row has three columns, and so on. So it is in the shape of a triangle, right? So we have to find a path which has the largest of the sums. We have to print the sum of the largest path, right? So, and also he specified that a path, we can consider a path as either going a step down directly or taking a bottom right step, right? So for example 1, we can either choose 2 or 1. We can't choose both. We have to step in one direction. In this in the case of this one, we can either choose 2, which is directly below it, or 3, which is slightly to the right side of it, right? So yeah, we can select these paths, and then we have to see the optimal path which has the maximum sum of the numbers, right? So for example, let's take this one. So 1, now 1 and 2. So let's say we choose 2, right? 1 plus 2, 3. Let's say again we choose 2, which is 5, and then we choose 1 or 1, which is, so let's 6. So this is one path, right? Let's see another path. 1, 1, so the sum is 2, and then again 4, the sum is 6, and now I'll take 3, so the sum is 9. This is the maximum possible path, guys. So here is the answer, 9, right? So we have to find the maximum possible sum in any path. Okay, so as you can see, we can't directly choose the best option in the next row. See, for example, here after 1 and 2 are possible to see as the elements of next row, but we can't just choose 2 because it is the biggest. We have to see further steps also. So in this case, greedy method doesn't really work. So what we need to do is I think I'll be using dynamic programming to solve this problem, and I'll be coming from the bottom, so that for example if we choose 1, we don't have to check the upper value. In this case, we can only check the left value directly, right? So that will save us some time, I guess. Yeah, so I'll be coming from the bottom. You might have a question, how can you determine the path when you're coming from the bottom? From the top, what is the path? Down or down right? So from the bottom, it's either up or top left, reverse of this, guys. Okay, so yeah, using that rule we can solve the problem. Actually, I did the problem before, so I might view my solution if necessary, just in case like I get confused or something. This is my solution. I'm not ripping off someone over here, so don't worry. Okay. First we get the input, then let's see the rows of this triangle. Then so let's create a list. We actually need a 2D list to store this. So let's create the first level of the list, mat, and then in range of n, let's do t equal to, this is another list. There we go. So we need to append t to mat. So now the numbers in this line are considered as a list. So not just this line, like for each line we take the string and convert them to a list of integers, and then that is assigned to mat, right? So we'll be having a list of lists, so that will represent the 2D array, I guess. Yeah guys, I'd also like to use another 2D array of same dimensions, like the same shape, but for each value we are going to put it as 0, right? So the reason that we are doing that is the next array, so the ct mat will act as let's just change the name, let's put it as weights. So this is another array which will act as the weights array. So I'll I'll explain it in a bit after I do the code completely. So guys, I'll just write the code for now, and then maybe you guys can, I'll explain you guys bit by bit. Right. And so I'll explain the weights in a bit, but this loop, why we are using this loop is, so we have to go from elements, right? So when we are starting from the base, I'll be using a function which will determine the what do you say, the weight of all, let's say the weight of all of these things, right? So, or rather I should say the paths from this element to all the possible all the possible paths from this element. Okay, so let's say if it's 1, we can choose 2 or 1, right? So this will be one path, 1 2 1 will be one path, and 1 1 will be another path, right? So we have to see what will be the best path which has the highest sum, and then it will return it. So the best possible sum starting from this element will be returned from the function. So for in this example, 1 plus 2 plus 1, which will be 4, will be returned instead of 2, right? And then we choose again with 2. Now we'll get 3 obviously, and then with 3 we'll get 4. So we got 4 here, we got 3 here, we got 4 here, and then we are checking with answer. If the current answer is less than what we are getting with this element's path, then we update the answer, right? So we just check which element's path has the best sum, and then we update the answer to it, right guys? So oh sorry, oh yeah, sorry, this could we could choose one. Oh sorry, this doesn't have an option to go right, you can only go left, right, in the reverse. So 1 2 and 1, which will be 4, and then here we have 2 1 1 or 2 2 1. So 2 to 1 is 5, this is the best optimal solution, and then again with 3 we have 3 1 1, so that will be 5 again. So this is giving 5, this is giving 5, and this is giving 4. So we choose either of these two, which is 5, so that will be the answer. The same in this case. Yeah, so now we have to design a function func, so that we can explore all the possible paths, right? But without getting a stack overflow, because we'll be using recursion in this case, right? So what the parameters that we are passing is the matrix, which is the triangle, and then the length of the triangle. Then this will be I1, this will be J1, and then this will be, let's say, W, or let's say WV, right? So I1 and J1 are the node that we the element that which at which we are right now. Okay, that will be the I1 and J. We'll use those as in index values to find out that one. So now if I1 is 0 and J1 is 0, then we just return add of I1 J1, right? So we just return the value. If we get to the last element, then we just return that element, right? So 1 in this case and 1 in that case. Okay, and so if it's not that element, so what should we do? So let's say we are at 1 right now. What are our possible paths, right? So first of all, we are using a matrix called weights, right? So here this is where the weights matrix comes into play. So if the weights is not 0, if the weights of I1 and J1 is not 0, so if W in this case, I1 and J1 is not equal to 0, then what do? We just return that thing. So what it represents is, if it is 0 means it is unchanged. If it is not 0, it would mean that we have already explored this path. So for example, okay, let's take an example. And so if we are starting from 3 in the first iteration, we have two paths, right? 1 or 4, right? So we get one value when we use this path, and then we get another value when we use this path, right? So if we what we are essentially doing is storing the best sum when we are going through this path. So when we are going through 1, we'll be storing it in the weights function, so that when we are checking with this one value, now what are the possible paths? 2 and 1, right? So this is overlapping with 3 and also 1, right guys? So you get it? So now we don't have to compute the same value twice for 3 and 1. If we compute for 3, then it's fine, then we can just use it for 1 again, right? How can we use it for 1? Well, we are storing it in weights function, weights matrix, right? So I'll show you how we are doing it, but this case basically accounts for if we have already changed the weight, which means we have already explored the path, then we can just return it, right? Okay, so I'll do one thing. I'll just edit this code a bit so that we don't have to have multiple things. And also there's a small check we didn't perform over here. So we have to see that the indexes are actually inside the range of the matrix, right? So if it goes out of the range, then that's not good. Well, you could ask, how will it go out of the range? I'll show you why. Okay, so the reason that I didn't use I and I just checked for J is cause so I is the row index and J is the column index, which means if I1 is 1, or rather if I1 is 0, it means that we have already reached this one, and in that case J1 will also be 0, right? It cannot be 1 when the I1 is 0, right? So J1, we only need to check for J1, because when I1 is 0, this will be true, and we'll just return this one, right? So for J1, what we are doing is we need to check that it is always greater than or equal to 0, obviously, because we are using 0th indexing, and we don't want to go left of 4, which would be array index out of bounds error or something like that. And also we also need to check that it is less than or equal to I1, right? So why we are using I1 and not N? Because this is not a perfect matrix, and I1 is the indicator. So for example, here I1 is 1 and we can only go 0 1 and 1 0 and 1 1, right? So it could only be less than or equal to I1, right? So and then okay, so if so in this case, if it is equal to 0, which means we haven't explored the path, then what do? We change the weight, which means we will be exploring the path now, and we'll be assigning it to this element. The weight will be changed, right? So and then we'll be returning it. Else, which means if it is not 0, then this won't get executed and we'll directly return the weight value, right? So we don't need to do another if else or something like that. We can just use the this is just a small trick to lessen the amount of code that we're using, right? Now here is where the magic happens. So what should we write here? Well, we're exploring the path, right? So what will be the what should we return over here? Well, we have to check what is the max of, well, what are the possible paths. Either we can go up or we can go up left, right? So we have to represent both of those things, which we'll be using for which we'll be using function calls of the same function. So we are recursively calling the function to check on other things, right? So this will work because at the worst case it will go to this position and then it will terminate. This is the base condition, right? So now what do? Well, mat and then are constant. We don't even need to do anything to those things. And then what do we have? Well, we have I1 and J1. Well, I1 should always change because we are only interested in the upper rows. We cannot go from this element to any other element in the same row, right? So I1 should always be less than the current one. And by how much? Just by 1, because we are only going one level up, right? So let me just copy this one into here because this is same. But now the column value, which means we should either go here or here, right? We have to choose one path over here. So if you're choosing this, the value of this will be same as this column wise, right? They are in the same column. So J1, right? So the same J value will be used. Otherwise, in the next case, what will this be? This could be the top left. So what does that mean? So this is 1 0, right? This is 1 1. So and what is this? 2 1, right? So this is 1 0, this is 2 1. So we have to decrease the row value by 1 and also the column value by 1, right? So I1 minus 1 and J1 is also decreased by 1 so that we can account for going top right, and then V as V is same, right? So if we haven't explored the path, we'll explore the path and then we get the maximum possible of both the paths, right? We are only interested in the maximum possible sum, so we are using the max function over here, and then we update the weight and then return it. Else, which means if the weight is already assigned, we just return the weight, right? So this will reduce the amount of computation that we have to do and also will reduce the number of recursions and the stack and that kind of stuff, right? Okay, so this is I think this is well and good, so we should be able to get the answer. Let me just check. We should get 5 and 9. Okay, there is an error. line 6. What is happening? Greater than. Where is greater than? Um, wait, what? So what if it is not in the range? Well, it's not in the range. Yes, we have to. Okay, so if it's not in the range, we'll just have to return 0, which we can do by doing this. Right, guys? So if it is 0, then it will execute this. Else it will come out of the else if completely and then return this. Right? We'll check if that's working. Okay, so we got list index out of range. Okay. Oh, so that's why we can't change the code so easily. Let's see if we actually handle. Yeah, I thought of the same thing. Yeah, so let's just put the return 0. Oh, sorry. Here we go. Oh no, this is getting 1 and 1. Okay, guys, so apparently something is going wrong. We have to see what it is. Oh, okay, so yeah. Okay. This is a silly mistake. So what is happening is we have to actually use this one, right? So we aren't adding. So here we are taking care of what is the best path, either this one or this one, but we are not actually adding this one, the actual number to the weight. So we have to do that too. It will be I1 and J1, right? We have to add the current element to the next possible paths. Then we'll be getting the 5 and 9, right? So yeah, this is working. Let's submit it once and see if it's fine. It should be, and it is. So yeah, guys. Yeah, it's a little messy, but it's really simple if you think it through, and this can be very useful, this paradigm, the dynamic programming paradigm, in many problems. So try to understand this problem as much as you can. If you have any doubts, put it down in the comments. I'll definitely answer the comments, and yeah, like, share and subscribe if you like the video, and yeah, see you guys in a bit.